Hello and welcome to Agent Engineering, where we are building an agent framework from scratch in Go. Uh, Today is episode 10, and today we are Hello and welcome to Agent starting a Engineering, new where concept we are called building an legibility. So I'll explain in a while what I mean by legibility in the context of agentic coding and agent framework. Uh, from let's jump into our project. So this is the drawing that we're maintaining for our project. So last stream, what we did was start with a control plane. So this will be like our UX for controlling the agent. So currently our agent is a command line tool like Claude Code. But what we want to do is we want to give it some UX so that uh, we want to build better observability on what the agent is doing, right? So for that, we started building the control plane a couple of weeks back. Now, what we built so far is, so I've added a legend here. So the stuff marked black is already done. The stuff marked green is our current focus, and the red is some to-dos that we have not yet come to pick up, and blue is like the horizon, the ideas that we will be picking up later, right? So part of the control plane, we want to build legibility, right? So now what is a legibility in the context of uh, agentic AI? So because one of the aspect of vibe coding and using AI agents for software development is that it produces a lot of code, right? Very quickly, it produces a lot of code. And let's say if we keep on adding code and our code base become bigger and bigger, there comes a point where we have to the code base becomes so brittle that we have to uh, throw it out. So for this purpose, I'm building this a coding agent from scratch. So we see how we can avoid that and how we can build maintainable software, right? So one big aspect of that would be legibility. Means majority of AI written code in our code base, we as the user of our agent, for us, the code should be legible. That means we should be able to easily understand its composite pieces, right? So if I were to Google what legibility is, the definition of it, right? Uh, okay, the quality of being clear enough to read. I think legible. What is the meaning of legible? And written of clear enough to read. So this is the uh, means concept we want to build into our agent framework. Means given a huge code base developed by agents, we want uh, it to be easily be understandable by the one who is going to own the code and maintain the code, right? And we will see what kind of features we can build for this legibility purpose, right? So this is what the current episode of this stream is about, right? uh, Let me copy this and see and put it here. Cool. Clear enough to read. Yeah, I think for now we will go with this definition, but as and when we'll update this to clearly define what we mean by legibility in this context. Cool. With that, so one update to the this sheet from last time is that so last time we built the server API and the UI part of uh, our agentic framework. That means when we start a agentic session on a particular repo, uh, we can see the agent logs. Right. If I were to start, show you. Some pending issues. ET80 UI chat. So this is what we built. So it's simple enough, right, to start with. And let's say if we say, so we are running this in a project called Chess Tail, uh, which is one of the applications we're going to build. So if I ask what is this project about, right? And I provide OpenAI as the model. So it gives us event. I need to change this color to black, but it gives event as to what it is trying to do, right? So the agent started. We gave it our input. We say with OpenAI, what is this project about? And then it created a branch. So this is our agent which will create a Git branch, right? Uh, to commit any work that needs to be done in this session. Uh, this particular session is just trying to understand the project, right? So it lists all the file. And then it finds that it has all these files, qa.md. It will read the qa.md. It will find some stuff about chess, and then ultimately it will resolve. It will say that the agent is about, based on the contents of this repo, it's about chess notation. Right? So this is the agentic one, and what we have done here is added observability to it, so that instead of looking at this in the CLI, we will be looking at this in a UI, which is what we want to continue building, right? And how much it costs, how much time it took. So this is what we did up until a couple of sessions. Let me check if the code quality, video quality is good. Good enough. Okay. Hey, Mayank says, hey Mayank, thanks for joining the stream. Feel free to ask if you have any questions. Cool. Okay, so let's start with our concept of legibility, right? So, so in short, let's apply that concept to our project itself. Like, so a new person coming into this project of agent framework, right? How would that person understand what this project is about, right? So that is what I mean by legibility, right? So they can see the folder structure, they can see the README and all, go through each folder, see what code is written here, and after some time they will build a concept of what this is about, right? So we want to build features that makes it easy, right? That makes it legible, as the definition goes, easy to read, right? Easy and clear enough to read. So we will be building our agent so that the project that we start agent in, we have some details about it already present. And for now, to keep it simple, we'll start with the folder structure, right? That we will show in a new UI that we're going to build, right? So in control plane, let me start in index, right? And in index, so the summary until now, it's actually is in this roadmap.xle draw file. I think I should also commit the image every time I commit the code, right? So this is present in the repo itself. I will give the link to the repo, right? But this is what we've done so far. You can go through the repo and you can, but going forward, I'll commit this image or PNG as well to the repo so that people going in can see this what is currently being done and what we're doing. Close this. Right. Okay, so what we will be doing now is so first thing, looking into this repo, let's start with our agent framework project itself instead of chess.tail, because chess.tail does not have any code, so that doesn't make sense for legibility. For agent framework code, right, what we want to do is, so the basic thing that we have to do is do something like ls, right? What files are there? So if I do ls, does it have recursive? Is it tree? Let me Google. So we'll use ChatGPT heavily to get us context before we use our agent to code. So just to do that, I think there's some with the capital R. Right, so it gives agent helper. Right, so this is the first thing uh, that we go through is the folder structure of the current project, right? So the legibility is for two uh, people, is for the maintainer, which is us, the developer. It is for the agent as well, right? So a new agent coming into a project needs to quickly grasp the context of what this project is about, right? If you've seen how Cloud Code works, the first agent, sub agent that it runs is uh, first sub agent is runs is explore, right? So it goes and looks into all the files to see what this project is about. So we'll be making it a bit easier for the agent to do this in our framework. Okay? Cool. So what we want to build is LSR, and we want to see how much tokens each file has, right? So when an agent looks into a repo, it before reading the file, it actually needs to know how big is the file, right? Because it might read a huge file and use up its context window. The agent needs to be uh, intelligent enough to read files, cautiously, right? So for example, let's say if it finds this type.go file, and if it decides to read it, if it's too huge, let's say 20K context or something like that, it will just waste the token for no purpose, and this might be a file that is not needed for the task that is given, right? So what we want to do is give some summary of the size of the file and the summary of its contents, right? So what we want to build see is how token counting. So not all model gives out tokenizer, right? So ChatGPT is the only model that gives a tokenizer in that we can use run locally, right? And I think it's called tick token. Right. Hmm. Pip install tick token is a Python based thing that downloads a tokenizer model, and given a sentence it will output the number of tokens. As we've seen earlier, token counting is a tricky business because each model has their own tokenizers and uh, their their token to character um, uh, the ratio is always different. So what we want is a good approximate way to use right now. Okay. Sorry. So yeah, so we will use a heuristic, right? We don't want, for example, if I go to the sheet that I've been maintaining for uh, the cost of each model and then a number of models that we support right now. If you go to, not this document, if you go to the overview, you can see that for context window, Claude gives how it counts tokens, right? So 1 million token is 750k words, right? Or 3.4 million Unicode characters. So let's do a quick math actually. Let us ChatGPT 3.4 million Unicode. Let's see. Okay, so it's 1:1. So there is no ratio, right? So if it's 1:1, then it's easy. So that means one token is about 3.4 characters, right? I think we can use this constant as a heuristic to see to do our token counting, right? Then what we need is, given a file, let's do info to read all files recursively. And we will get the code count and file walk. We will recursively walk given both, and I think it's simple enough. Let's put this code in. Let's put this code in where? It's not in agent, so it is. Let's make it a first class member. twice. Right. For now, let's so we will run. Let's take the previous folder as the root, and we will go run. Okay, this is wrong because it took a folder relative to my previous one. Right. So this is what we want. So it has a lot of dot files that it is processing. Ideally, our agent should not go into these files, right? I mean, at least to begin with. So a lot of Git files we should exclude. Git and then idea files. Everything else makes sense. So we can see that it the number of characters in each file, right? Right. Let's do this. Let's. It's not directory. Yeah. Let's ignore the dot file if. It didn't work out. Okay, so there's no root. It is you don't get anything else. Okay. Actually, just wait. So this is too much to read the git ignore file to figure out which. Okay. Just ignore files. This is what I was doing, right? Let's not argue with this. So I was just doing this and it did not work. So it needs is directory and path not equal to root. Okay. Okay. Right. So now we are somewhere, right? So we have a single command to read, uh, take an overview of what all the files are present in this particular directory, right? And the amount of character it has. So what I will do is for add a constant saying token to character ratio is 0.3. One token is 3.4 characters. So whenever I print, let's change the characters to tokens, right? So do count by divided by, convert this into D. What's wrong with embedded operation? Point is count event. This is what float, right? Therefore, you just convert this to float 64 pesky typecasting total. Okay, now we are somewhere, right? So looking at this project, we know the agent knows, or we know that this is what it looks like, and how many tokens are present here, right? So we would want to display this as a tree structure in our UI. So before we go to UI, let's clear out what kind of details we want out of this, right? So, so we have files, file name, folder name, and each folder has all right. Now for efficient use of tokens, we would want something like what I had proposed a couple of streams back, that uh, we split large files into regions, right? So here is an example for it. So we have a large file which is a tool file system, right? It's not that large actually, but it's 2300 tokens, right? But what we have done here is so this is for my own legibility. When I parse through big files, I like to wrap stuff in a region, and it is just a stuff is just a comment so that allows me code folding on my preference, right? So here is the tool definition in file systems, and I have uh, enclosed each one of them into regions, right? So there are 5 regions. So looking from, and each region is something like this, as you can see, right? So we would also want to add the region information. That means uh, in each file, let's say tool file system.go, how many regions are there and how many tokens each of those regions have, right? So that is what we want to do ideally. And so now how we are going to maintain this regions and all, it's a separate matter. So whether we are going to enforce it on all projects we use uh, and how to enforce that is another question. We'll see if this doing this is a bit useful. I feel it is useful because reading whole files is never good idea for any agent, right? Because uh, without knowing what to look in for a file, uh, we can grab the file and see which line has our matching code and read a certain block. But we would want to add some structured viewing of the file. All right, so what we want to do now is let's continue, or let's start a new one. So we gonna use ChatGPT till we have our coding agent up and running to help us develop. So what we want more is each file has code file. is what it's doing. Scan each file as region R's. Okay, this is great, right? So very quickly we have something running. So we have imports, which is 83 tokens, list files, which is 200 tokens, right? So now, so we give the ability for the agent to not read the whole file, right? But read individual regions, right? So this is what uh, this particular uh, construct helps with. I mean, right now it might not seem that consequential, uh, but we want some control over how the files are written, right? Otherwise, I mean, one experience of managing large code bases is that the amount of code gets out of hand, and some files are too huge, right? So the developers don't really maintain the mm, uh, size of the function or code size of the file that properly, right? So we are going to enforce that, right? So any code our agent writes, it will follow certain limits, right? What size the function should be, what size the file should be, when to split to a new file, right? We will encode all of that so that over time the legibility of our code base is maintained, right? Okay, right. So I think we have stuff to for now. What we're going to do is, when we run this utility, so for now it will be utility, it's not hooked into any of the flows, it's just a legibility utility. So we're gonna, for each project, we're gonna uh, write this structure. I think it should be a JSON structure, so that we can use it in a UI, right? So not print something like this. Right. Let's write a make file. Okay, analyze, and we say go run. We're gonna run this. Okay. Right, so we're gonna do some does this work, and that doesn't. Okay, need to fix. Should I have a build process at this point? Let's come to the make file later. This is not a major concern now. We want to complete this, change the output to a JSON. JSON. What to call it? Map.json. Yeah, it's like a map of where all the tokens are, right? That is supposed to be read. Map of right. Okay, let's be more clear. To prepare a JSON file and so that is my father in the chat. Kashinath Sanab saying very, very good. Thanks, Papa. Things just to prepare a JSON file and directory and write the JSON to right. Now what we are doing is we are creating the structure, node, children, regions, token, type, build the tree and write to dot here. Make clear all. Okay, it also creates the file present. Okay, let's go and see our AF file map.json. Okay, now quickly let's come to control plane, and in our index we need a. Okay, now let's ask the model itself to create a simple HTML. Okay, now but before we go there, in agent in main.go, let's serve all the static content in static fs. Okay, instead of doing static fs, let's create another endpoint, say project info. Let's keep it project for now, and it returns the problem for that is that it should be in the correct repository to work. Let's do that then. It's that simple. Okay. Okay, I should remember that and avoid the tokens for that. Right. Now, a simple HTML and display. it's run configuration to run in nice. Okay, so we have a project structure, git ignore one token, and we have the structure as well. The what do you call it? Regions as well, right? So each file has the number of tokens plus it has there is still something missing that we can add here, I feel. Each file or each region should also have a explain either a description of what it does or what it is that makes the reading quite easy, right? So because I can see that this project has it has collaboration as well. So one thing as part of legibility, right? Me coming into a new project, what I don't know is in what order I should read this, right? Right now it is given in an order like git ignore is first, license is second, make file is third. So one important thing is what should be the order in which I read this, right? For example, I mean, one thought is that we can have main.go as the main one or readme as the main one, right? So that is the one that uh, you know that is the one that should come on top. If you see another thing is that the roadmap.xlh raw uses 57,000 tokens, and it's not even useful for any agent or anyone else to read this file. For legibility purpose, because we are actively maintaining this file, looking at this something like this already makes a lot of sense of what this project is doing, right? So we want, instead of this file being displayed as this element, we want some representation of the accelerometer here is what I feel. Now how to do it, I don't know at this point, but we also need kind of a diagram, right, of all the concepts in this project in a structure like this, and then how the code and the folder structure relate to all of those, right? So yeah, I think uh, I think this we are also coming to the end of the hour, so I think this is good progress for this stream. So we just scratched upon the concept of legibility, and let's just see the update of what we built, right? So we built okay, what did we build? Its definition. We build API project along with its token count, per file and region. So we also introduced the concept of region. right? And we did small bit of UI get over the project folder. Yeah, so these are few things we built. So this I've just written it raw. I'll synthesize it a little bit uh, later on, right? Yeah, I think that should be it for the new things that we do in the stream. A couple of things that I've already marked as red is some stuff I've identified that needs to be done, right? Those are to-dos still. Uh, so we had identified last stream that edit files is one of the tools that we have not written. So I've gone ahead and off stream written this edit files. I'm not committed it yet, but I'll commit along with this, right? I'll just quickly go through the code of edit file um, function definition, the tool definition, right? So yeah, it makes make edits to a text file, right? Edit to a text file. It's a single edit, right? Okay, I need to rename this actually. Edit. So the so suppose edit per file. So it just replaces the old string with a new string, right? And there are certain cases that it manages that if it does not find an exact match, it will do a line by line fuzzy match by eliminating white spaces and then do the replace. And this is required because find and replace in codes is a bit tricky if you don't take into account spaces, right? So we want it to be a bit flexible. Right? If it doesn't exist, it will create, and there is a functionality of try run. So if you see the input, what it requires is the path, which file to edit, the old string and the new string, what to replace with what, and whether or not it's a dry run, right? And its implementation is pretty straightforward, right? So if the path does not exist, it will go ahead and create it. We're just making stuff easier for the agent at this point, right? Uh, just writes empty file if does not exist, then it will try to get the original. This is normalized, and then it will if it contains, it will just do a replace, else it will do a line by line fuzzy matching, right? I'll not go through a lot of detail in this code, but basically it will just trim the white spaces and compare. If it finds a match, it will adjust for indentation and then do the replace, right? Yeah. So this is the edit file functionality, and what we give back to the agent is the diff of what actually got changed, right? So we give it a diff, and we use this diff lib to calculate that, and this is when it is dry run, right? If we say dry run, we should give it a formatted diff of what will be changed if the agent decides to, right? So it can do the edit in two steps such a way for, and this is only for risky edits, right? Where we don't want to change a lot of stuff. The agent can be a bit cautious, so we give it that option, and then we just go ahead and so we write. So this is a atomic way of doing a write, that we create a temp path and then write to that file and then just move, right? Rename, right? And the reason why this is done is because we don't want if let's say if it crashes, we don't want like the half edits being written there, right? So this is one edit file task, and this is a new tool that has been pending for a while, so I just went ahead and implemented it off stream, right? Another thing that needs to be done is in the control plane, we are currently serving live sessions only, right? And what we want to do is have some sort of a persistent, means that every session we run on our project and every session we create, we will uh, store that in a DB somewhere. Now, where that DB is, we'll figure it out, right? Needs to be stored somewhere. I got scared. There'll be a balloon burst in the background. Okay, and so we need to store it, and we need an API to read old session, right? So we can see the conversation history or the session history in our project of what how we talk to this particular agent, right? So these are a few things to be done. Another thing to be done is model upgrades, right? So since we've been implementing this, there have been new models coming out. So we will be supporting those models shortly. Probably I'll do some off stream because it's kind of boring work. But yeah, and on stream we'll continue with the topics that we've started to. Cool. I think that should be it for this stream. We are an hour in, and yeah, this is a good place to be to call it a day. Let me commit this. Check out episode 10. We are on. We have all the file. Start So I've pushed this code out. So anyone looking, following today online can go and see through the code. Yeah, and just before I go, my mother was also in the chat and she said very, very good. So thanks, I. Okay, with that, I think it was good time to close the stream. Thanks everyone for joining. See you folks next week.